Today we're working on the Geometry Chapter 4 review. Number 1, it just wants to know if those triangles can be congruent, state why, and then give their congruent statement. So on number 1, I have a pair of angles. I can get these vertical angles on my own, but if you take a look at your markings then, angle is not enough information, so my answer is not possible. Let's take a look at number 2. Okay, I see a pair of angles that have been labeled. I see a pair of sides that have also been labeled. And again, I see vertical angles that I can get on my own. So if you take a look at your markings, we can get those triangles congruent by angle, side, angle. I'm going to write out that congruent statement. I have IFJ is congruent to triangle HGJ. Number 3, again, I have a pair of sides, another pair of sides, and I can get that third pair of sides on my own. So we have side, side, side. Triangle KLM is congruent to triangle KNM. Number 3, again, I have a pair of sides, another pair of sides, and again, I can get that third pair of sides, so my triangles are congruent by side, side, side. I have triangle OPR is congruent to triangle OQR. If you look at number 5, I have a pair of sides, I have a pair of angles. Angle side is not enough information, so here's another case where it is not possible. Okay, moving on to question number 6. The first thing I'm noticing is I have a 62-degree angle right here. These two form a linear pair, so in other words, A plus the 62 gives me 180. I'm going to subtract, and I end up with A is equal to 118. These two angles are vertical, so that means B is equal to 62 degrees. And then finally, I see this tick mark here. So it looks like this angle here is going to be the same thing as these angles here. So these two are the same because this triangle is isosceles. So the first thing I'm going to do is I'm going to go ahead and take 180 minus the 62. That gives me 118 degrees, and I'm going to divide that by 2, and I end up with 59 degrees for the measure of angles. Okay, moving on to number 7. Again, I have an isosceles triangle. So if this is 3x minus 10, this angle is 3x minus 10, and now I can see these form a line which is 180 degrees. So we're going to add the like terms. I see 7x plus 5 equals 180. 7x equals 175. And finally, x is equal to 25. Number 8 says I have a vertex angle, or excuse me, an isosceles triangle, and the vertex angle, which is up here, is 34 degrees, and I have to find the measure of each base angle, which is here and here. If these sides are congruent, then each of these angles are congruent. I'm going to label each of them to be x. I have x plus 34 equals 180 degrees. I'm going to combine like terms and go ahead and subtract the 34. Finally, we divide and we end up with x is equal to 73 degrees. Number 9, it wants me to separate and redraw why the triangles are congruent. Alright, so the first triangle I see is up in here. I'm going to see if I can pull that triangle out. I've been told this is 3, this angle is marked, and the other thing I'm noticing is both of these angles have that angle in common. Let's see if I can pull out the other triangle. Again, this angle is marked, which is the C. this distance up here is 3, and again I have this angle in here as being the overlapping angles. So if you take a look at your markings, I have a pair of angles, the second pair of angles, and these sides have the same length. That means they're congruent. So finally the triangles are congruent by an equal angle side. Moving on to number 10. I'm told these triangles are congruent. I just need to make sure. Sometimes you guys jump the gun and you think that these two angles are the same. But if you take a look here, E corresponds with R. So E, that means these angles are the same. So this is 3n minus 24. I'm going to focus on this triangle here. That means the sum of all of those angles. So I see a 3n minus 24. A 4n minus 10 plus 90 has to equal 180 degrees. So I'm going to combine like terms. I see 7n negative 36 plus 90 is going to give me a 54 is equal to 180. So 7n equals 126, and finally n is equal to 18 degrees. Pause and double check my math. Alright, I did find a mistake. This is a 56, so now 180 minus the 56 gives me 124 degrees, and now divided by 7, and I end up with 17.7. Number 11, I have the measure of one angle and an equilateral triangle is 5x plus 50. If you recall, every angle in an equilateral triangle is equal to 60. We're going to set that equal to 60 and solve. Alright, number 7, we're trying to prove URY, so that's one overlapping triangle up here. So let's take a look at your markings. You have this. We would also have this whole length. And I have this side up here that they overlap. Let me show it to you again. If I'm looking here, this whole length is going to be congruent to this whole length here. I have this angle here is congruent to this one, and that side up there they both have in common is RU. So take a look at your markings, side, angle, side. Okay, moving on to number 14. It says all of the following are always true except. So the first one says AR is congruent to UT. That's true if you take a look. It's the second and third location. Second and third location. Next one, RF. That's the third and first. And T and U. That's not the third and first. So it looks as though our answer would be 2, but let's continue. F and R, T and O. That's correct. Next, ARF, so second, third, fourth, and OTU. ARF and OTU. We'll go to there as well. Now that was a little confusing. The main thing I was making sure that R and T are in the middle of those naming the angles in there. Okay, number 15. We're looking to prove which triangles can be proven given the hypotenuse leg. The first thing you have to have are right angles. If you take a look at number 1, you do. The second thing you have to have is a hypotenuse. Well, we don't have these hypotenuse, so this one cannot be proven. Number 2, we don't even have right angles to start with, so that can't be proven. Number 3, again, we don't have right angles, and we don't have any information to lead us to believe they're right angles, so hopefully that leaves option 4. You do have right angles here, we have the legs here, and we have that hypotenuse right there. So the answer for that one is 15. Okay, question 16 I think actually is a picture on the back side, so I'm going to see if I can't redraw that for us. Okay, so it tells me I have two sets of parallel lines. It wants to know why are these triangles congruent. Well, first of all, if these lines are parallel with that transversal, I would have these alternate interior angles congruent. If I have the other vertical pair with that transversal, then I have those angles congruent. So right now I have an angle, and I can get that reflexive piece on my own. And so finally I can see the triangles are congruent based on my markings, angle, side, and angle. Okay, continuing on to the back side. Number 17, it wants to know which piece of information would not help us prove that those triangles are congruent. And I've been given an FAC, this angle in here is congruent to FCA, which is this angle here, and I'm going after the bigger triangles. So I'm going to go ahead and separate those out. Twice. And I do have this reflexive side on my own. So the first thing it says is that AD and BC bisect each other. AD and BC bisect each other at point F. So that information doesn't even pertain to these two triangles, it pertains to the smaller one. So I don't think that piece is going to help you out. Let's go on. DA, which is in this triangle right here, is congruent to BC, which is existing in this triangle. That would help to get them congruent by side, angle, side. Let's go on to the next pair. Angle B is congruent to angle D. That would give me, so I have to pretend that part wasn't there, unfortunately. I have this angle here and this angle there. That would work because I would have angle, angle, side. And finally, BAC and DCA are right angles. BAC, so I'd have this right angle here, this right angle here, and again, I'd have angle, side, angle. So it ends up just being answer 1. And I'm going to stop here because all of the rest of those are proofs, so I will do that on the